Hey guys, it's Miss Johnson, and I'm here to bring you your notes for Unit 5, Notes 1. We are moving into Unit 5, which is all on quadratic equations, and today we're going to talk about finding the vertex and the y-intercept of a parabola. So our learning target for today is I can identify parts of the parabola. So let's just talk about what quadratic equations look like and that funny word parabola and what that means. Your standard form of a quadratic equation is kind of the equations that we've been looking at, or the expressions I should say, that we've been looking at in Unit 4. We talked a lot about factoring in Unit 4, and most of the things that we factored had that x to the second term. So our standard form is anything that can be written as ax squared plus bx plus c. And this is what makes it quadratic. Anything that has an x to the second power is quadratic. So our linear equations, the equations that we've been working with for most of the year so far, were y equals mx plus b. That was x to the first power. Now that we move into x to the second power, these are called quadratic. So you're going to hear that word quadratic all throughout this Unit 5. The graph of a quadratic equation is called a parabola. So the graph of a linear equation that we were used to, the graph was a line. The graph of a quadratic is called a parabola. And a parabola makes this U shape. And it could be a U like that, or it could be a U opening up like that. So let's just talk about the different parts of a parabola. So, like I said, we've got U's that could be opening up like this, and we could have U's that are opening down like this. So the first thing, probably the most important point that is in a parabola, is called the vertex. It says they have a point called the vertex. This is the starting point when you graph a parabola. This is the first thing that you need to find. It's also the maximum or the minimum. So up on your graphs, we're just going to identify these things in our pictures. This right here is the vertex of that graph, and that is also called a minimum. And over here on this one that's opening down, that's the vertex of the parabola, and it is called the maximum. Now, the thing about the vertex is that it marks. The nice thing about the vertex is the fact that it marks the point of symmetry. So we all remember symmetry and what the concept of symmetry is. Same on one side of the other, kind of like you can fold it or look at it in a mirror. So the parabolas are symmetrical, and they're symmetrical about this line called the axis of symmetry. So these kind of dotted lines right here are also called the axis of symmetry. And again, it doesn't matter if it's opening up or down. An opening down parabola also has the axis of symmetry. And if you'll notice, the axis of symmetry goes right through the vertex. So you can see that the line that is the axis of symmetry is through the vertex. Same thing over here. The line that is the axis of symmetry goes through the vertex. That's not a coincidence. It runs through the vertex, and it has the same value as the x-coordinate of the vertex. Okay, so the axis of symmetry is the same thing as the x-coordinate of the vertex. Okay, one other point that is nice for us to find, and it's a point that we're familiar with, we used it in linear equations as well, is the y-intercept. We know that where the parabola crosses the y-axis is called the y-intercept, because the same was true in linear equations. It doesn't matter what type of function you're graphing, the point where it crosses the y-axis is always called the y-intercept. This is also the constant of the quadratic function, or in other words, this is the c term. The one at the end, that's the constant. So in this case, up in our pictures, that would be my y-intercept. Or over here, this would be my y-intercept. And one other thing to note, because we've been looking at these two different pictures, is what makes these equations open up or open down. So the graph of a parabola will open up when your A term, is positive. Or in other words, A is greater than 0. And the graph will open down when A is negative. Or in other words, A is less than 0. So you can tell right away from looking at the equation what type of parabola you will have. Will you have a graph that opens up, or will you have a graph that opens down? Sometimes we call them smiley or frowny. Is it a smiley parabola or a frowny parabola? All right, so let's just kind of put this into practice for one example. Here's our steps, because again, like we said, the most important thing about graphing these parabolas, or the place that you have to start, is the vertex. So finding the vertex is the first thing that we need to do. This is going to be crucial for you. This formula right here, that x equals the opposite of b over 2a. Opposite b over 2a, opposite b over 2a. You're going to hear me say that a lot. So when I'm looking for the vertex, the first thing I have to do is find the opposite of b over 2a. That gives me the x-coordinate. That also gives me the axis of symmetry. So I've got both of those things just from the opposite of b over 2a. Okay. Now for the vertex, that gives me the x-coordinate. Once I have that x-coordinate, I plug it back into the original, which we all know how to substitute, simplify, find the y-coordinate, and then the vertex is a point, x comma y. So remember that the vertex, the axis of symmetry, is the x-coordinate of the vertex. Okay, so we're going to see what that looks like. So let's try one. Number 1, we have the equation y equals 2x squared plus 8x minus 3. So good thing to know, what's your a, what's your b, what's your c? A is with the x squared term, b is with the x term, and c is the constant at the end. Next thing, you can determine right away if it opens up or opens down. You look at that a term, and since that a is positive, I know that this graph is going to open up. And you can tell yourself why so that you have these in your notes. A is positive. Then the axis of symmetry. So I need this guy. X equals the opposite of b over 2a. Your b value is 8. Your a value is 2. So that's negative 8 over 2 times 2. That's negative 8 over 4. That's negative 2. So the axis of symmetry is x equals negative 2. That's also going to be the x-coordinate of the vertex. So you can put that in there right away because you know they're the same thing. But then to get the y-coordinate, I need to plug it back in. So y is equal to 2. Use parentheses. Do yourself a favor. If you don't use parentheses, your calculator is going to tell you that negative 2 squared is negative 4, but we all know that negative 2 squared is positive 4. So negative 2 squared, like I said, is positive 4. Positive 4 times 2 is 8. 8 times negative 2 is negative 16, and then negative minus 3 at the end. 8 minus 16 is negative 8, so this is going to be negative 11. So that is the y value of my vertex. And the last thing that we can use to help us graph these is finding the y-intercept, and the y-intercept is pretty easy. That's the c term, and the c term here is negative 3. All right, so we're going to go ahead and stop our video there for today. Thanks for listening, and I will see you all tomorrow in class together. Don't forget to hop back to Schoology and take that Schoology quiz, and I will see you tomorrow.